So right now we are at the second module. We are considering difficult ground conditions, and we have already considered surface water flooding. It is can be effect of huge amount of rainwater or increasement of fluctuations of the of the water level at the river, and it leads to the open water on the surface. And to protect our building from surface water, both pluvial and fluvial rain, fluvial river level or lake or something like that, we have to increase planing marks, compact these soils, make drainages, to perform works in a good way to also prevent good water protection, and also to make special embankment of territories from river to protect our building from the effects of this difficult ground condition. Next difficult ground conditions, we usually consider them in pair. So first of them is karst, and the second of them is subversion. And when we are talking about those difficult ground conditions, we have to understand that both of them have same effect on the surface. It leads to sinkholes, both of them connected with the water. But main difference between karst and subversion is caused by the structure of the soils where those water moves. So first of all, when I'm talking about the karst, it is a situation where it's like an impact on the tablet of paracetamol or other medicines which you can throw in the glass with water, and it starts to dissolve. Same situation we have with grounds which under the impact of water or aggressive water with some kinds of acids or salts dissolves, and this dissolution of soils leads to the underground sinkholes. Next effect, which called subversion, it is also the impact of water on the soil, but compared with the karst, it leads to different type of effect. It leads to movement of small particles of soils between the big particles of soils. So all the soils, they consist of big and small particles. And when we have water flow moves little particles between the big particles, and during certain time we will get only big particles with emptiness between them, and then this soils which consist of big particles, it falls down, and it will also lead to sinkholes on the surface. Sometimes we can get those sinkholes underground, under the roads, and you have seen such sinkholes during last rainfall, which caused to the falling down of cars under the ground. And it can lead to solution sinkhole when it dissolves the soil. It can also lead to collapsing hole when we have not such situation but big emptiness on the ground. We can go also caprock sinkhole, dropout sinkhole, and subversion sinkhole. Here is the subversion sinkhole. Also, too, we can get such thing as buried sinkhole. So we don't have. We can see big a cave from the above of the soil, but it had emptiness under the ground. And here are the photos and screens of the karst effect. So karst, it's a complex geological process of dissolution of soluble rocks, and it from surface sometimes it can looks like this. When we will analyze this section, it will look like this. So Here are the caves which were created by water. And just imagine if you will start the erection of the building on such soil, it will fall down under the ground. And there are a lot of stories in the history of construction where in one moment big buildings went underground because of the sinkholes or karst, because of karst or submersion sinkholes are under those buildings. Next effect, which I already explained to you in few words, it's submersion. When we have big particles of soil, small particles of soils, and movement of water flows will replace the small particles, and it will, as a final result, it will lead to such effect where we have such result on the surface. And to analyze the effect of karst and of karst, we have classification. Here we have six categories, and the category is not as simple as we discussed it in case of the mm, for example, undermined areas. Here, this classification is connected on amount of because both we have also two types of classification. So first of the classification is connected with the amount of sinkholes per 1 year per square kilometer. So if you will analyze, for example, territory 20 square kilometers, and on that territory during year you have got two sinkholes, that will mean that on per 1 square kilometer you have 0.1. So two sinkholes on 20 square meters, it will mean that you have 0.1 sinkholes per square kilometer per year. And it will lead us to the second category of karst dangerous territories. So first classification, amount of sinkholes per year per 1 square kilometer. Another type of classification is much simpler. It is connected only with the diameter or median diameter of the sinkhole. So, for example, if you have sinkhole with a diameter 5 meters, it will lead you to the category V. If you have a sinkhole with a diameter 25 meters, it will mean that you have the category A. And so here are the effects of submersion. And what do we have to do when we are designing buildings on such difficult ground condition like karst and submersion? So first of all, we have to perform planning solution. So what kind of planning solution which will not give the ability to water be collected in certain points. So where we don't have a big amount of water, we will not get the problem with karst and submersion. Next, it's waterproof and anti-filtration. So to protect our site or source or ground under our building from these impacts. Using various geotechnical strengthening of foundation, constructive, structural, technological increase the reliability of communication. So, for example, you can leave special wires with sensors near the pipes on the ground, and that will give you an ability to uh, mm, to react fast quickly. So if the pipe will get any leakage, the sensor will detect that leakage, and it will inform you about the leakage underground. So you will have to turn off the crane to stop the water transportation, to repair the pipe with the leak, so it will save your soils from underground water impact, which will lead to the sinkhole. And also, like monitoring, as we told, as I've just explained you. So, as it's told, vertical planning, water leveling, the vertical leveling solution. So, when we have certain planning marks which will protect our construction site from collection water in certain places. So, like one in clean, where all water moves in one direction and collected in certain drainage system, it is the best solution. Preventing of accumulation of surface water in pits and sites, etc. Also, lowering of the level of ground water with the with help of drainages, reductions of groundwater flow gradients, and equipping return filters with special filters. Also, when we have such problem like sinkhole and it already happened, we have to plug it with concrete or other mixtures to make consolidation of those karst rocks, to make those voids under the ground completely filled with concrete, or lightweight concrete. Also, there are such solutions, or can be filled with the sand and gravel. Also, can be sold like this. And the best solution is to support our building on reliable non-karst fixed soil. If we have not big layer, for example, 10 15 meters of soils with karst, we can make piles with the length 20 meters. Forget about karst, because our building will be supported on the reliable ground. Next, what we have also to discuss is special design solutions for the foundations on piles, or natural foundations, etc., on natural ground sand, above foundation and floor belts and space frames to make buildings rigid. Also, we have next difficult ground condition which we will discuss today. It's abrasion. Abrasion, it's a coastal effect. It's a result of impact of sea or ocean waves on the coastal part of the dry land, which leads to interesting effects like this or like this. These, by the way, these are made in Odessa region. And we have also to protect our building from the abrasion, from the impacts of waves. And what do we have to do to withstand such type of difficult ground conditions? So first of all, it's to make wave protection, to make damping wave energy consumption constructions, and also beach restraints, which we always think that they made for rest or for tourists, but main function of most sand beaches is to protect the coastal part of dry land from the effect of the sea. And next difficult ground condition, which we will also discuss today, it is landslide. Landslides, it's very dangerous difficult ground conditions. The difficult ground condition is widespread around the world, and it can lead to significant consequences. And it's a movement of big mass of soils because of moisturizing or destruction of the uh, soils under the buildings or other elements on the construction sites with different ground marks and something like this. And I think you have seen a lot of situation which looks like this. By the way, right now there are a lot of Ukrainian construction companies at Bali, and at Bali they have a lot of landslide construction sites. And sometimes when uh, they have bought construction site to erect small 2-3 story townhouse village, they have to spend more money to prevent the construction site from landslide than on the construction of those buildings. So that makes those real estate really expensive. Also, we will discuss the landslide causes. So first of all, it is connected with the stress state of the rocks of the slope. So can be connected with the increase of steepness or other types. And next, it is the cause which is connected with the decrease of strength of rocks and soils. Sometimes it caused by the impact of water. So colleagues, also main measures. What do we have to do when we have a construction site with landslide? It's to make retaining on supporting structures and foundation to make foundations with streamlines and which will withstand the pressure of ground, which also changes of relief of slopes. Agroforestry, it's gardening of trees on such sites, because trees can connect the ground very well, and the roots of trees can withstand the landslides very well. Also, chemical consolidation and landslide zone soils and coastal protection structures. And here are those measures. It's like massive retaining walls or retaining wall like these, or it can be retaining wall with pile. It can be a retaining wall which looks like this with the substitution of soil. Massive masonry retaining wall. It can be a retaining wall with special ground anchors, special elements which goes deeply in the ground and which holds these elements from the curvature of sliding. Various type of piles or such elements, massive or retaining wall with piles, or uh, retaining wall with special ground anchors. And when we're talking about the situation with landslides in Odessa, we have a complex situation because we have to withstand both abrasion, landslide, etc. So, and in the situation of Odessa, we have a complex solution to this. So, first of all, to reduce the pressure of this ground, to remove part of the ground. Second, to make a special retaining walls, to make water barriers, to make sand beach, and all these solutions will give us an ability to protect our uh, slopes. But when we have, and you have seen the situation a lot of when all the sand beaches were eaten by the sea and the waves uh, strikes our retaining walls, that makes situation where this slope of movement, this curvature of movement of soil will lead that part of this ground will be in the sea. So these are typical situation with difficult ground conditions, which can occur in Odessa. And today we have completed part of difficult ground conditions which were connected with impact of water in various types. And next lecture we will start from the effects of all difficult ground conditions on building, and then we will talk with you about seismicity, seismical impacts of about seismic resistance of architectural design of seismic resistance building. So that's all for today. Do you have any question? Have you? So if everything is clear, that's all for today. See you next week. Thank you. Bye.